Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of optimization. So as per the problem, the base of a rectangle lies along the x-axis and the upper two vertices are on the curve defined by y equals k squared minus x squared. Determine the dimension of the rectangle with the maximum area. So the first step is to analyze the given equation of the curve. This equation represents a parabola. It will become more apparent if we rearrange the terms in this equation. If we compare this equation to the general equation of a quadratic function, we can see that there is a reflection over the x-axis due to the negative sign with the x squared, and that means the parabola is opening downward and there is a vertical translation k square units up. In this equation, k represents a constant. So if I have to sketch this curve, it will look something like this. So there is an important concept we need to understand to solve this problem. Now this curve will cross the y-axis at point k squared. So if we sub in x as 0 in this given equation to find the y-intercept, we get y equals k squared. So that's the y-intercept or the vertex of the parabola. Now we can draw a rectangle whose base lies along the x-axis. This parabola is symmetrical about the y-axis. The y-axis represents the axis of symmetry of this parabola because the vertex lies on the y-axis. This rectangle will be symmetrical about the y-axis. So there's another important concept we need to understand for this problem. Let's assume the end of the rectangle on the positive x-axis is at point A. Therefore, the end of the rectangle on the negative side of the x-axis will be at negative A, and the rectangle crosses the y-axis at point B. Therefore, the coordinates of the other two vertices will be A comma B and negative A comma B. Now we can write the length and width of this rectangle in terms of A and B. The length of the rectangle is 2A and the width of the rectangle is B. Now since point AB lies on the curve, we can sub in x as A and y as B in the given equation. So this gives us the mathematical relationship between A and B. We have to find the dimensions of the rectangle that will maximize area. So let's start with the area equation for the rectangle. Area is equal to length times width. So area is equal to 2A times B. Now we have to find the maximum area. So we'll have to find the derivative of the area function. Now the area function is defined in terms of two variables A and B. So we'll have to do substitution for one of these variables, and we can do the substitution for B because we have an equation for B in terms of A. Now we can simplify this equation by distributing 2a into the parentheses. So this is the area equation in terms of a. Now we can write the domain for this function. The length of the rectangle is 2a. So a cannot be equal to 0 or less than 0. So therefore a can only be greater than 0. Now as per the equation that we got here, b equals k square minus a square, the maximum value for a will be k, because if a exceeds k, then b will become negative. So that means a has to be less than k. So there's a very important concept we need to understand to solve this type of problem. Therefore, the domain for this area function is a is greater than 0 and less than k. Now we can find the derivative of the area function. In the first term, 2k square is a constant and it's the coefficient of the term, so it will stay as it is, and the derivative of a is 1 minus 2 is the coefficient of the term, so it will stay as it is, and the derivative of a cube as per the power rule is 3a squared. Now we can set the derivative equal to 0 and solve for a, because we have to find the maximum area of the rectangle, and at the maximum point in the area function the tangent will be horizontal. That means its slope will be equal to 0 or the derivative will be equal to 0. Now we can solve for a, so we should add 6a squared to both sides. Now we can divide both sides by 6. And this fraction can be reduced to k square over 3. Now we can apply square root to both sides. As per the domain, a cannot be less than 0, so we can ignore the negative solution. So the valid solution for a is, and the solution also lies in the domain. Now we can check if this value of a, k over square root of 3, gives us the maximum area. So we can do the check for the area of the rectangle at the endpoints of the domain and at this a value. So let's start by calculating the value of the area at a equals 0, the lower end of the domain. So we'll sub in the a value as 0 in this area equation. So I get 0. Now we can calculate the area at the value we got, k over square root 3. We can subtract these fractions by finding a common denominator, and we should multiply the first fraction in the numerator and the denominator by 3. Which is equal to 4k cube over 3 square root 3. So this is the area we get for the a value k over square root 3. Now we can calculate the area value for a equals k at the upper limit of the domain. So I get 0. That means the area is maximum at the a value k over square root of 3. Now we can write the dimensions. The length of the rectangle will be equal to 2a, and a is equal to k over square root 3. So the length is 2k over square root of 3. Now we can find the width of the rectangle, which is equal to b, and we can use this b equation. B equals k square minus a square, and a is equal to k over square root of 3. Now we can simplify this expression. So we can subtract these fractions by finding a common denominator, and the common denominator is 3. 2k square over 3. So the width of the rectangle is 2k square over 3. So these are the dimensions that will maximize the area of this rectangle. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.